Guys, sorry I couldn't be here today or be in class with you today, but we are going to still plow ahead with changes of state. This is again for learning goal B2. So changes of state, it's just a conversion or a change of a substance from one physical form to another. Just like going from ice, melting that into water, and then when that is heated, it will turn into water vapor. So we're getting into the different states of matter. We've got the solid, liquid, and gas. Remember, this is a physical change only. We're not talking about chemical changes here, just physical. So really what we're getting at when we're talking about changes of state is actually the amount of energy. If energy is added to a substance, then the particles are going to move faster. Therefore, it's going to go into a different state of matter. If we're adding energy, it's called an endothermic change. If the energy is removed, if we're taking it away, the particles are going to move slower, and that is called an exothermic change. Temperature is actually a pretty good measurement of the speed of the particles, and therefore it gives us a clue as to its energy. Transferring energy, which is also known as heat, actually causes the temperature of a substance to change, which can also lead to a change of state, although that's not necessarily true in all cases. The first change of state that we're going to talk about is melting, which is just going from a solid to a liquid. As you can see in that example that I've given, an ice cube is a solid and it's changing to a liquid, and therefore it is melting. This is the change of state from a solid to a liquid, and it has a specific point called the melting point, where the temperature at which the substance changes from a solid to a liquid, that's the melting point. This is going to vary, or it's going to depend greatly on the substance. Some substances have a really high melting point, others have a really low melting point. Every substance is slightly different, and actually, you can use a substance's melting point to help identify what it is. It's called a characteristic property. Melting is an endothermic change because we're adding energy to it. Okay, so again, endothermic is adding energy, and therefore that energy is absorbed by the substance as it is changing its state. Freezing. Freezing is the opposite of melting. It's going from a liquid to a solid. It's a change of state that occurs at its freezing point, which is the temperature at which that liquid changes into a solid. I included that picture because that's, I'm sure, how some of us feel like midwinter in northern Maine. Freezing is an exothermic change because energy is actually being removed, or it's being taken out of the substance as it changes state. Vaporization. Vaporization includes two things, and this is going from a liquid to a gas. It includes both boiling and evaporation. So boiling is vaporization that occurs throughout the whole liquid, and it only occurs at the liquid's boiling point. If you look at the bottom of the picture there on the left-hand side of the screen, that's the boiling point. When the water is warmed, those water molecules are going to escape really, really quickly because they're moving really fast. Evaporation, on the other hand, it occurs only at the surface of a liquid, and it occurs below the liquid's boiling point. So if you look at the top of the picture to the left there, when the water is cold, very few molecules will actually evaporate. They don't escape very easily. Here's an interesting little tidbit of information. Atmospheric pressure can actually affect the boiling point. Boiling point is not consistent from place to place. So in areas where the atmospheric pressure is really low, it can actually cause the water to boil at lower temperatures. So for example, in Denver, Colorado, which is one of the highest places in the country, actually it is the highest place in the country, it boils at 95 degrees Fahrenheit, which is much sooner than water here in northern Maine. Condensation is going from a gas to a liquid. We talked a lot about condensation when we discussed the water cycle. It's a change of state from a gas to a liquid, and it occurs at the condensation point. Believe it or not, this condensation point is the exact same temperature as the boiling point. This is where the temperature at which the gas becomes a liquid. Energy has to be removed for condensation to occur, because it's going from a gas to a liquid, and the molecules are slowing down, so the energy is being removed. It's therefore exothermic. Sublimation is a really fun one, and it's not one that we really think of very often. It's going from a solid directly to a gas. In other words, it doesn't melt. Okay? Dry ice is a really good example of this. Dry ice doesn't melt, which makes it really, really great for transporting certain materials, especially materials that can't get wet. For example, medical materials, they can't get wet, and therefore dry ice is a really good way to transport them. Sublimation is actually adding energy and is therefore an endothermic change. Okay, the key of this lesson is to remember, if you're adding energy to something, it's an endothermic change. So you can see if I'm going from a solid to a liquid, as with ice going to water, I'm actually adding energy. Therefore, melting is endothermic. If I'm going from water to water vapor, I'm again adding energy because it's going from a liquid to a gas. Therefore, evaporation is also endothermic. If I'm going to go in the opposite direction, say going from a water vapor to water liquid, that's condensation. Therefore, I'm removing energy, and that's exothermic. Again, if I'm going from the liquid water to ice, I'm removing energy through the process of freezing. Again, exothermic. Okay, one last thing before I end this lesson. Temperature change and change of state, they kind of go hand in hand, but there's a really key point that I want you to remember. The temperature is not going to change until the whole change of state is complete. So if you look in the picture down below, you see that as we're adding heat, we're adding energy, it's going to continue as a solid, or the substance is going to continue as a solid until it reaches its melting point. It is then going to stay at that melting point until the whole substance, the whole ice cube, for example, changes into a liquid, and then the temperature is going to increase again. And then as our temperature increases, it will eventually reach the boiling point. And again, it's going to stay at that boiling point, at that temperature, 100 degrees Fahrenheit, for example, for boiling water, until everything has vaporized, and then it will continue on, or the temperature will continue to increase as a gas. The opposite is true if you're removing energy or removing heat. This is kind of a tricky chart to figure out. I would like for you to look at it, and if you have questions, make sure to ask each other or do some more research. You can also email me, but it is really essential that you start understanding this concept of heat and temperature and changes of state, because we will be revisiting this time and time again. Okay, again, if you have questions, let me know. Email me and feel free to do some research on your own. Hope this lesson helped. All right, guys, welcome to my living room, which is, I think, one step above the poor guy who was recording everything in his basement. Thank you for bearing with my little lecture there. I apologize if it got a little boring at times. Changes of state, as exciting as they can be, are a little bit hard to translate through this medium, this format. Before I just absolutely left you, I wanted to make sure that you understood what my expectations were for you this week while I'm away. The first thing, now that you have actually submitted your projects and you've gone through my lecture on changes of state, I want you to take a second and complete this write about note taker. This note taker has three main parts. Number one, I want you to draw a picture or multiple pictures of something that I discussed in my lecture. I also want you to list some keywords about the topic, and I gave you plenty of keywords to select there. I want that whole box completely filled in. Lastly, you also have to write a paragraph that summarizes what you learned by using the terms that you listed above. So as you use the terms, make sure to check off the keywords, but also circle the terms in your paragraph. I expect this whole note taker to be completed at the end of class on Tuesday. On Wednesday, I have created a crossword puzzle for you. The substitute does have the answer key, so you will be reviewing it together as a class. You will also complete a quick changes of state worksheet in which you have to go through all the 6 different changes of state and identify whether they are endothermic or exothermic changes. Again, you will correct this or review it together as a class. On Thursday, you're going to begin a changes of state poster project. Again, I'm not a huge fan of poster projects, but this will be a nice change up from the keynote projects you've been doing lately. On Friday, you're going to continue and you're going to finish up those poster projects. If you finish early, I have provided the substitute a practice test. You will be having a test next Tuesday, and I want you all to feel adequately prepared for that test. So please take some time and actually review this material. We won't be spending much time reviewing on Monday because I expect that you will have already come to a good understanding of the concepts. Okay, if you have any questions, please feel free to email me, but this should give you a pretty good rundown as to what I'm looking for the remainder of the week. Have fun!